Greetings, dear participants of the CGIAR Big Data in Agriculture Convention. This is Gkanogiannis. I am the lead bioinformatician for the Crops for Nutrition and Health research area of the Alliance of Biodiversity and CGIAR. In this short video, I will present you my winning solution for this year's challenge on wheat growth organized by CGIAR Big Data Platform and Zindi. My bosses were not very confident in me that I have data scientist capabilities, so I devote this prize to them. As I am a little busy right now trying to navigate my way through the Colombian departments, Polly from Amazon will help me a little with the presentation. Enjoy!
Some 20 years ago, when I was still young and naive, I decided to take an artificial intelligence, machine learning class as a physics undergrad. Big mistake. Back then, things were still pure and innocent. So, for the final assignment of the class, I decided to build an artificial neural network. The recipe included plain clean C language code, a network with a simple input layer, 2 hidden fully connected layers, and a single node output layer. Simple sigmoid activation functions, and plain straight back propagation weights adjustment were used. I decided to train it to recognize the pattern or function the telephone company was using, to issue valid codes from a deck of used cards I already had. For novel purposes, of course. Anyway, this didn't work out as I was expecting, which is not bad. Otherwise I might have ended up somewhere like there. Fast forward some 20 years later, a bunch of hippies start to add weird stuff, like convolution layers, ReLU activation functions and more hidden layers, and more activation functions, and more hidden layers, and suddenly all persons with a computer on the planets decided to become data scientists, while using weird alien script. Don't forget, endangered species, notebooks and laptops, and all these requiring expensive Dutch cheese to run on. All these were not enough. They also had to change the name. Okay, enough with being serious and all this stuff. Let's get a little funny and silly now. For this challenge, organized by CGIAR Platform for Big Data in Agriculture, I treated the problem as an image classification one. The organizers gave us a bunch of pre-classified images of wheat fields, each one representing the wheat growth stage of the field, into one of 7 levels, with 7 signifying a field ready for harvesting. Apparently, the classification of the training set was done by a drunk hippopotamus that had never seen a wheat field before. That is why a lot of train images look like being into the wrong class. Or it is night. Or it is not a field, just a road. Luckily, the organizers had marked some training images as good assignment quality. The hippopotamus must have been sober, and these were the training set images that I used. Unfortunately, only 5 of the classes had training images of high assignment quality. I used Darknet. No, not that one. The one that, as Joseph says, is an open-source neural network framework written in C and CUDA, because as you remember. I am not sure though what was Joseph's dog contribution to the design and implementation of Darknet. For network architecture, I used YOLO v4, which is a convolutional neural network framework designed and implemented by Alexei, the successor of Joseph in developing Darknet, and it is primarily a fast real-time, object detection framework in images and videos. Obviously, it can also be used in image classification mode, where each training image contains a single object, the whole image, belonging to the class of the image. Classification of test unknown images is done by presenting the image to the trained YOLO network, which will detect 1 or more objects of the 7 classes in it. The image is finally assigned to the class of the object that was detected with the maximum confidence.